Hello everyone, my name is Alondra Zaragoza and I have made a walkthrough video on how to analyze wireless frames in Wireshark. I will demonstrate how the data is seen in layers 2 through 7. I will also show you how an unencrypted frame looks like compared to an encrypted frame. Wireshark can reveal a lot of information on a frame and can also show us what happens to the data once the encryption is applied. Let's get started. So what is Wireshark? It is a free open source tool that is used by many organizations to analyze their network in real time. It is a type of packet sniffing tool that intercepts traffic and captures data packets and displays that data in an easy to read format. It can help organizations identify the reason why there is slow internet connection, the reason why data packets are getting lost, detect malicious activity, intercept man-in-the-middle attacks, and trace voice over internet calls, among many other things. Let's start off with layer 2, the data link layer. This is frame 8 and it is unencrypted. I click the line that has IEEE 802.11 data to reveal the information. Here you can see the MAC addresses. We can see the receiver, transmitter, source, and destination MAC addresses. The receiver is the device that the AP is sending the frame to. The destination is the intended MAC address. The transmitter is the MAC address of the device that sent the frame, and the source is the original device. The data link layer is responsible for delivering the frames using MAC addresses and makes sure that the frames are being received by the correct device. Next, we have layer 3, the network layer. I selected the line that has Internet Protocol version 4 to expand and see the data below. Here we can see the IP addresses of both the source and the destination. In this layer, the packets are moved from one network to another network and allows the devices to communicate to other devices located in other wireless network segments. Layer 4, the transport layer, searches for problems such as dropped packets. In this section, I selected the line that says Transmission Control Protocol. We can see that in this section, the TCP shows the ports for both the source and the destination. The source port is 20 and the destination port is 1105. The transport layer handles the communication between devices and makes sure that the data is delivered in a reliable way by either using the TCP or UDP. In the application or layer 7, we see that Wireshark demonstrates the plain text of the data that is being transmitted. It reads, "These are the times that try men's souls." In this layer, the data that is unencrypted can be easily seen. Next, we will look at frame 136, an encrypted frame. So I scroll down to frame 136, which is an encrypted frame, to look at the data we can see. The layer 2 MAC addresses remains visible even though this is encrypted. The reason why is that the AP needs to be able to deliver the frame to the correct device, so in this instance, it is okay to have this type of data visible. All right, so here is a side-by-side comparison of an encrypted and an encrypted frame. Can you spot the difference? What is missing? Okay. If you look closely, in the unencrypted frame, we were able to see the IP version 4 and the TCP section information. In the encrypted frame, we do not see that. So this means that the WPA2, the WPA3, has encrypted these two types of information, so we can no longer see the IP addresses nor the ports. All that we can see is the encrypted payload. As you can see on the bottom right corner, that's all we're seeing. Lastly, as you recall, in the unencrypted frame, we could see all the data that was being sent when we looked at the line-based text data. Here's another difference between the frames. On the unencrypted frame, we saw a line that said line-based text data. On the encrypted frame, we see a line that says data or 48 bytes. Once this line is selected, all we can see is random numbers and letters or bytes. This is because the encryption has been applied to the frame. Now that we have seen and compared frame 8 and frame 136, we can see the differences between what unencrypted versus encrypted frames looks like and the importance of why encryption is necessary. And that is to protect the data that is being transmitted wirelessly from attackers while still being sent correctly. Thank you for your time. And there's my resources.